Good afternoon, everyone. It's 1 minute to the hour. We have a good set of attendees. And thank you for coming to C102, Data Observability, the next frontier of data engineering. And who you are seeing is not Bar Moses. It's Bar's double. And I'd like to introduce Molly Vorwick. She is a member of the Monte Carlo data founding team and head of content, and she'll explain why she is not Bar. But before we hand it over to Molly, just to emphasize to post your questions in the chat, in the Feedloop chat, and to remember to go over to the networking session after Molly's session to engage in additional conversations, or if there were any questions that Molly did not get to. And Molly, take it away.
Thanks, Chrissy. Hi, everyone. My name is Molly Vorwerk, and as Chrissy astutely noted, I am not Bar Moses. Bar, unfortunately, had a medical appointment that she could not reschedule. She's fine, don't worry. But as a result, you're stuck with me. So I am head of content at Monte Carlo, where Bar is the CEO. And so today I'll be talking a bit about data observability and how it really complements your data stack and kind of takes your data quality and trust to a whole new level. So without further ado, let me share my screen. All right. Today we'll be talking, as I mentioned, about data observability. I am Molly. I am head of content at Monte Carlo. So before we kind of get into the nuts and bolts of this topic, I thought that I could introduce myself a little bit. As I mentioned, my name is Molly. I lead content at Monte Carlo, which is a data reliability company. Monte Carlo is the creator of the first ever end-to-end data observability platform, which I'll talk a bit about what that even means in a bit. So before I came over to Monte Carlo and joined the data world, previously I led technical content and brand for Uber. I ran their engineering blog and helped their AI team publish research papers and the like. Before that, I was a freelance writer with USA Today, where I covered history and culture. And before that, I studied at Stanford University. And a fun fact about me is that I actually wrote my honors dissertation on Elvis Presley. So I can answer any question you have about Elvis in a little bit, but kind of before then, let's talk about data observability and first data downtime. So today, we're going to walk through what data downtime is and why you should care about it as a data professional, why the best data teams are adopting software engineering best practices to tackle it, and what these tactics might look like in practice. So at Monte Carlo, we help companies deal with data quality issues. And so we're very familiar with them. And that's actually part of the reason why we founded the company, because there really was not a holistic approach to solving them. And so we refer to data quality issues as data downtime, and I will explain why. So now that we've kind of gotten those things out of the way, what is data downtime and why does it matter? It's no secret that everyone at your company relies on data. In fact, the reason you're at this conference today is because you probably embody one of these data personas and are looking to learn more about what the future of data looks like more broadly and how some of these trends and technologies might fit into your practice. You might be Rebecca, who is a data user who relies on real-time insights to develop punchy marketing strategies. Or you could be Anna, an analyst who is widely referred to as the SQL queen of her company because she wrangles data like no one else in magical ways. Or maybe you're Emerson, a data engineer who's responsible for building and maintaining your company's data platform using Snowflake, BigQuery, Redshift, Looker, Tableau, any of those awesome tools. Or maybe you're Michelle, a manager or chief data officer who relies on business intelligence platforms to generate crisp, insightful dashboards for her CEO, showing how awesome your team is. The point is that a lot of people use data, and it's important that you can trust it. But what's common to all of these personas? Regardless of who you are, you've probably experienced some version of data downtime. Because when downstream consumers tell you that the data is wrong, and I'm sure it's happened to many of us, even at Uber, when I was responsible for overseeing like content engagement, sometimes Google Analytics would be down, and that was a no-no if an executive wanted to know how much engagement a given piece of content had. So that could be an example. Another example could be, a model doesn't run, a pipeline pauses, there's missing duplicate or null values in your table. And it can be caused for a variety of reasons, and I'll get to some of them in a little bit. But regardless, when data downtime happens, you have a serious problem on your hand. These data issues have so many repercussions, not just for your direct team or CEO, but the company and your customers too. And when this whack-a-mole game comes about of, the data is down, what do we do about it? Where did it happen? How do we fix it? I've identified 3 primary costs. The first one, not being able to pinpoint the root cause of these data issues, let alone identify them until it's too late, means that your team, your data engineers, your stakeholders are firefighting instead of spending time on revenue generating activities. Whether that means building new products, responding to customers' requests, or even developing strategy. In fact, we found doing some internal research with the customers that we work with, as well as some other widely cited studies, that data teams spend about 30 to 40% of their time firefighting data quality issues. And that is a significant chunk of time when you think about how much time you could be spending on revenue generating activities. The second big issue is not knowing if and when data broke, and it opens up the door to compliance risks. This is more pronounced if you're in financial services or healthcare, but every industry who regularly handles customer data is also facing massive fines or even lawsuits if data is misplaced or mishandled. GDPR is a big one nowadays. CCPA. There's several other different compliance measures when you're in the financial services or healthcare, HIPAA, so on and so forth. And then third, and perhaps most importantly, and ironically, given the goal of data, is the erosion of trust. And this could be the trust of your downstream consumers, whether that's an analyst or a manager, or even your product or service customers. Data is supposed to be the truth, separate from gut-based decision-making, so to speak. But if you can't rely on your data pipeline to deliver on this promise, then you're not unlocking its true potential, and your customers will no longer be able to rely on your product or service. So these are just 3 of the implications of, data quality issues on your company, and why we think personally that it's not given the diligence it deserves, because it has such wide-ranging impact, not just for the data team, but for downstream consumers as well. But, as I mentioned, these repercussions often manifest very much downstream. So we looked into some studies, and according to Gartner, the average cost of poor data quality on businesses amounts to $15 million annually per business. And another stat is that actually 1 in 5 companies have lost a customer due to using incomplete or inaccurate information. And then finally, issues associated with missing, erroneous, or inaccurate data can account for up to 80% of a data analyst time. So there has to be a better way, right? There has to be a better way. When you think about software engineering and kind of the best practices that they've put in place to handle code quality, it's about time that data follows suit. So, the good news, if there is good news, I guess more comforting news, is that if this happens to you, you are not alone. This game of whack-a-mole, this lack of data trust affects everyone at every company across every industry. And we call this problem, as I've mentioned, data downtime. And no industry is really spared. Just a few months ago, it was reported that the US government sent over $1.4 billion in COVID-19 stimulus checks to dead people. The culprit? Outdated data tables. One CDO at a fintech company that we spoke with recently referred to this issue as the keep our CFO out of jail problem or priority because of the potential implications of poor data quality on GDPR. So what is data downtime? Let me draw a corollary to application downtime. A couple of decades ago, no one cared if your website was down because no one was using it. But today, that's absolutely unheard of. Every engineering team that respects itself has some way to manage the reliability and uptime of their applications. Clearly, the same thing is happening to data. In the past, we could afford for some of our data to be down sometimes, but now in this, decade of data, that's changing. Every company is using data and at massive scale and in real time. The situation I've been describing, this lack of confidence in your data, is caused by periods of time when your data is partial, erroneous, missing, or otherwise inaccurate. And all sorts of things can cause data downtime, from null values to duplicated data sets. But most companies have no idea when or where it happens in their pipeline until it's too late. So after speaking with hundreds of data leaders about their biggest pain points, the team at Monte Carlo learned that data downtime tops the list. And now, so more than ever, data downtime only multiplies as data systems become increasingly complex, supporting an endless ecosystem of sources and downstream consumers. So, we know it's not good, but what does it look like in practice? So during non-pandemic times, we'd ask the audience if any of these realities ring a bell and to raise their hand. If your company is experiencing data downtime, there's probably a lot of incident resolution going on. Your team probably spends at least 10% of their time fighting data quality issues, and they may have lost money because data was broken. And this may not be readily apparent on a case-by-case basis, but it builds over time, particularly when compliance infringements are involved. That is the kind of summary of what data downtime looks like. But wouldn't there be, but how are we actually going to address it? So now I'm going to spend some time talking about data observability, which is our solution to holistically looking at this larger problem of data downtime and poor data quality. Now, before I dig into what data observability is and what it might look like in your pipelines, I want to pay tribute to someone who is near and dear to my heart and probably to a lot of your hearts. They make sure that your favorite things like Slack and Netflix don't break. And if they do, that they're fixed before you can say Tiger King. This person is responsible for building, maintaining, and remedying broken things at nearly every company. And heck, you may even be one. I'd like to thank developer operations engineers, or more specifically, observability engineers, for giving us the kind of tools and frameworks with which to approach this problem of data downtime. And I mentioned, the issue of application downtime. When your websites or applications are not loading properly, or they're not working, or whatever it is, these engineers are responsible for fixing them. And so I think it's about time that we treated data downtime and data quality with the diligence that it deserves, given how widespread and scaled data operations are at most companies. So we believe that solving this problem and stopping bad data in its tracks can be tackled by relying on some best practices of our software engineering friends. So software engineers leverage principles of site reliability and observability to ensure that their applications are performing as expected and that uptime is high while downtime is low. So if you've never read Google's Site Reliability Handbook, highly recommend it. It outlines all of these principles in way greater detail and way better than I ever could in this presentation. But in a nutshell, it discusses how Organizations who are growing and building out their tech stacks can increase reliability and ensure that the downstream consumers, the people that visit their website, the people that watch or use their applications, do not suffer the effects of bad code or other issues. So in DevOps, observability refers to kind of taking a constant pulse on the health of your applications and systems. And so more specifically, it refers to the monitoring, tracking, and triaging of incidents to prevent application downtime. And as a result of this industry-wide shift to distributed systems from monoliths to distributed architectures, observability engineering has emerged as a fast-growing discipline. And at its core, observability engineering is broken into three major pillars, as you can see on my slide: metrics, logs, and traces. Metrics refer to a numeric representation of data measured over time. Logs are a record of an event that took place at a given timestamp and provide valuable context regarding when a specific event occurred. And traces represent causally related events in a distributed environment. On the data side, I've noticed, and perhaps others would emphasize with this, that approaches to data reliability and data trust, and generally data engineering, are about 10 years behind software engineering. In application development, every team has an observability solution like New Relic, Datadog, or incident management tools like PagerDuty to measure the health of applications and ensure reliability. And yet data teams are still flying blind. But solving data downtime, in other words, not flying blind, is easier than you think. And all it takes is a holistic, automated approach to data observability. So what is data observability? Well, if you hadn't guessed it already, data observability is an organization's ability to fully understand the health of the data in their system. Data observability eliminates data downtime by applying best practices of DevOps and observability to data pipelines. Like its DevOps counterpart, data observability uses automated monitoring, alerting, and triaging to identify and evaluate data quality and discoverability issues. This in turn leads to more reliable data, healthier pipelines, more productive teams, and customers that can trust the data that your service is providing. So what does data observability look like in practice? How can you actually follow in the footsteps of our engineering friends and apply observability to your own data pipelines? In the next few slides, I'm going to outline a few best practices for this that you can take away from this presentation and apply to your own systems. So just like you have three pillars of observability for software reliability, every data team has pillars of observability for data reliability and data trust. And I've broken these down into 5 major areas of data health that are strong indicators of whether or not something has broken or gone wrong: freshness, distribution, volume, schema, and lineage. So let's walk through each of these for a little bit. So the first one, freshness, seeks to understand how up-to-date your data tables are, as well as the cadence at which your tables are updated. Freshness is particularly important when it comes to decision-making, as we all know that stale data is basically synonymous with time and money. So how often have you been looking at a dashboard in Looker or Tableau or Mode and realized that the data is missing or outdated or does not represent the reality of the data flowing in your system? It's happened to the best of us. And so that's why freshness is one of the core pillars that you need to monitor and alert for when something veers from the norm. The next one is distribution, or a function of your data's possible values. Distribution tells you if your data is within an accepted range. So data distribution gives you insight into whether or not your data tables can be trusted based on what you can expect from your data. The third one is volume, and it refers to the completeness of your data tables and offers insights into the health of your data sources. So if 200 million rows suddenly turns into 5 million, you should probably know. And that could indicate that something is off. Now, that's not to say that every time that happens, that means that something is off. But if you are aware of what's going on in your system, you can adjust and, alert the teams that need to know to fix things accordingly. And so the fourth is schema. So schema refers to changes in the organization of your data. In other words, schema often indicates broken data. And monitoring who makes changes to these tables and when is foundational to understanding the health of your data ecosystem, not to mention preventing issues from occurring again. And so for data engineers, actually, we did like a quick survey among some of our customers, and data engineers say that the #1 cause of data issues for them is schema changes, because schema changes can throw everything off in a pipeline, particularly one that kind of runs automatically. So something to keep in mind, and I'm sure you've dealt with them if you are a data engineer. And then the final one is lineage, and in my opinion, my favorite and the most important one. So when data breaks, the first question that teams ask is always where. So data lineage provides the answer by telling you which upstream sources and downstream ingesters are impacted, as well as which teams are generating the data and who is accessing it. So good lineage also collects information about the metadata that speaks to governance, business, and technical guidelines with specific data tables. The lineage serves as sort of a single source of truth for all data consumers. And in our opinion, lineage or metadata without the other is useless. Teams are collecting a lot of metadata these days, but if you're not able to apply it to a specific business use case, then what's the point? And lineage helps you with that. So let's look at data observability in the wild. So I talked a lot about some of these concepts, data downtime, data observability, but what does this actually look like in practice, and how can data teams benefit from applying these frameworks and kind of technologies to their systems? So the first company I'm going to walk through is Blinkist. So some of you might be familiar with them. Blinkist is a kind of a company that provides 10-minute summaries of classic books, audio summaries of classic books. So during commutes, they can be quite fun and useful. And so this story I'm about to tell you relates to how data downtime affected them as a result of pandemic trends. So with over 16 million users, Blinkist helps time-strapped readers fit learning into their lives through their audio ebook subscription service. It's a high-growth company, and it leverages paid performance marketing to fuel customer acquisition. And their 2020 strategy, with an ambitious 40% growth target, included a significant investment in channels like Facebook and Google, which would auto-optimize campaigns based on behavioral data shared between the Blinkist app and the channels themselves. But like so many other companies in 2020, the pandemic changed everything. So when the pandemic hit, historic data did not reflect the reality of their audience's daily lives, and real-time data, accurate real-time data, became essential. And it wasn't just for determining advertising spend, but for understanding how users were interacting with the Blinkist app and content across the web. So any inaccuracies in this data could impact decision-making, from campaign spending to updating the product roadmap. It was crucial that no opportunities to innovate were missed. Because a campaign around improving your commute just was not relevant anymore because no one was commuting. So as C-level executives and campaign managers grew increasingly dependent on real-time insights to drive marketing strategy, budget spend, and ROI, the head of data engineering, Gopi, and his team were struggling with data downtime, issues with data quality, dashboard update delays, and broken pipelines. They couldn't trust historical trends for marketing to customers, and they needed a way to course correct and understand the health of their data. So to tackle this at scale, they implemented data observability to deliver visibility into their Redshift warehouses, ETL solutions, and Periscope dashboards. Now they actually have, a dedicated data reliability engineering dashboard and tools and a team. So by leveraging, data observability, applying the same principles of application observability, but to their data pipelines, they were able to monitor the health of data in real time so that when things veered from what they were expected or what they were striving to achieve, that they could be alerted and see what was going on. It could be that there was actually a dip in customer engagement, or it could be potentially that they were just not allocating the proper spend to the right marketing channels. So as a result, these incidents have led to 40% growth on marketing ROI because they better understand their data, faster incident resolution between data engineers and analysts when data downtime does strike, and 120 data engineering hours saved per week, which is a significant amount of resources that can be delegated to work on other things. So the next example I'm going to give is Yotpo. So Yotpo applied data observability to get a better health on their growing data system and how consumers were interacting with the data. So Yotpo is a e-commerce marketing company that works with e-commerce firms around the world to help them accelerate online revenue growth through reviews, visual marketing, loyalty, and referral programs, as well as SMS marketing. So as you can imagine, they deal with a lot of data, often in near real time. So over the past few years, Yotpo has grown exponentially, expanding their operations globally and acquiring companies including Swell Rewards and SMS Bump. So as Yotpo grew, so did the number of data set sources and the complexities of their data pipeline. And over time, it became harder to keep track of data completeness, lineage, and quality, three critical features of reliable data and pillars of observability. So data observability, once they started applying it, gave them an overview of their Redshift environment, including all of the data assets, schemas, and tables, as well as machine learning algorithms and how models were tracking. So as with observability, the platform was able to actually generate algorithms automatically that created rules for monitoring and alerting so that they didn't have to do all of this threshold setting manually. So another use case where data observability became crucial to Yotpo was when their business applications team, which is the group responsible for integrating and maintaining internal operational systems like Salesforce, wanted to replace an outdated field with a new one. Many of their dashboards heavily relied on this field, so they had to prepare in advance for the change. Using information-rich query logs, data observability helped with metadata. Data observability helped Yotpo understand what are the downstream dependencies for this field, who is using this table and how, which dashboards are currently using the old field, and where the new field has been added to track progress of this update through Lineage. So because of that, they were able to integrate with these systems and replace old fields with new ones that were more applicable and had more up-to-date data. So over time, as a result of applying best practices of data observability, Yotpo was able to increase cost savings, facilitate better collaboration between data engineers and analysts, and drive greater efficiency and productivity, and really optimize their data operations at scale. So those are some real world use cases, but if you kind of wanted to see a little more in detail, this is what data observability can actually look like in practice when you are kind of putting together some of these solutions. So let's walk through some examples of data downtime and how observability might be able to solve it. So let's assume that someone changes a field, resulting in missing or partial data. As a result, data observability, kind of understanding the data health, would give you insight into all of the dependencies of a field so that you can make changes faster with minimal damage. You can understand the entire lineage of your data system. The next one is, let's assume that your dashboard hasn't been updated in 24 hours, and there's no way you would know that unless you had something that was automatically detecting freshness issues. And so using kind of the secret weapon of observability, which I'll get into in a bit, and you probably already know what I'm talking about, you can do this straight out of the gate. You don't have to do this manually. And it allows you to get alerted in near real time. And then finally, Finally, miscommunication between members of your data team. So right now, I'm assuming at your company, many people work with the data, whether you're a data analyst, a data scientist, a data engineer, or even a business user, much downstream. Let's assume that miscommunication leads to a mistake in a model. So with data observability, you're able to rapidly triage and troubleshoot the data to identify the root cause and fix the issue fast, in the same way that you would use observability for application reliability. So those are just 3 examples of how how data observability looks like in practice, but what does this mean for your organization? And how can you actualize the impact of data downtime on your company? So here I have a very high level kind of look at how much money your company might lose as a result of data downtime. So we've kind of created this kind of rough estimation, but you would assume that you have X number of data engineers working on data quality issues. So it would be the number of engineers times their annual salary times 30% of their time, because there's, a stat that we had found that data engineers spend about 30% of their time fixing data quality issues or data downtime, plus any compliance risks you might have. So for example, in 2019, GDPR, if you were found to have infringed upon GDPR, you would have to pay 4% of your annual revenue. So that's where the 4% comes from. So adding that plus opportunity costs, which I know is kind of a challenging thing to account for, but it would be revenue that you could have generated if you had moved faster, released X products, and acquired X new customers. So the opportunity cost can change depending on the needs of your organization. But this is kind of, if you're trying to justify investing in data quality or investing in more reliable data pipelines and best practices, here's a helpful calculation that you can use. So another really important component of effective data observability is setting service level agreements and service level objectives to track its reliability. So many different industries, and engineering being one of them, use SLAs and SLOs to track how reliable their software is, in part for their own benefit and to build better systems, but also as kind of part of a contract with customers. So we promise you 5 nines of uptime if you pay us X dollars. And so if these SLAs are infringed upon or not met, then usually there's some sort of compensation. So the same applies for data. And I think, without having to go into how data uptime or downtime affects downstream customers, it could just be a good internal starting place to kind of help you create better hygiene habits for your data. So in data observability, you might leverage use or RED metrics to measure software, and perhaps you've heard of them. So U stands for utilization, saturation, and errors, while RED stands for rates, errors, and duration. And these calculations give engineering teams a good idea of how reliable their systems are based on downtime and how well equipment is being utilized. And from there, what needs to be done to improve system performance. So similarly, data teams can measure data reliability by setting SLAs and SLOs for data and leveraging novel metrics to track data downtime. So traditional measures or methods of measuring data reliability are often time and resource intensive. And the good news is that there's a better way to approach it through the novel data downtime measurement here that multiplies the number of incidents your data team has by the sum of the average time to detection for these incidents. So time to detection, time to resolution, similar for software engineering observability, but applied to data. incidents. So it would be number of incidents time, the time to detection plus the time to resolution, which would be the number of hours of data downtime that your team experiences, and from there you can set SLAs. So many of our customers swear by this measurement, and we hope it helps you as well. So, finally, if modern software engineering teaches us anything, it's that automation is your best friend. Nearly everything in software is automated these days, and for good reason. Why do something manually like QA testing or checking for bugs if you can just automate it? This lets engineering teams focus on projects that will truly move the needle for their company. And the same holds with data. We talked to data teams, looked into some studies from Harvard Business Review, the New York Times, and ZoomInfo, and ultimately concluded that data teams spend on average 30% of their time on data downtime fire drills, which I had mentioned before, that could be avoided if they were automatically monitored, alerted, and triaged. And so I'm excited for what's emerged from the data space in this category. And as I said earlier, that data teams are often 10 years behind their software engineering counterparts when it comes to building out their technologies. But we've reached a true turning point for the data industry. And some of the best data teams have begun to really prioritize automation, particularly as it relates to observability. And I'm excited to see where it leads. So before I wrap up, I want to walk through some key takeaways. I want to leave you with these three things. So if you don't remember anything else, remember this. First, and perhaps most obviously, data downtime is the biggest challenge our industry is facing. If we can't trust our product, our data, then why should data consumers trust it? The good news is that we can start trusting it by applying best practices of software engineering to alleviate this pain, primarily through data observability. Data observability is the key to achieving trust through data reliability, a must-have for any company serious about unlocking the potential of their data to drive innovation and maintain that competitive edge. With that, I thank you for attending this talk. I hope you found it valuable. If you have any questions, any at all, feel free to reach out to me at mvorwerk@montecarlodata.com, or you can find me on LinkedIn. I love chatting about data, and I love hearing about practitioner experiences and what keeps you up at night, in part because it helps me write better content. And then if you're interested in learning more about our approach, you can visit www.montecarlodata.com/blog. We post at least one new article every week about what's top of mind for data practitioners, often relating to best practices for data observability, data downtime, detection, and so on and so forth. So thank you so much for your time. I appreciate it. And so if anyone has any questions, please feel free to, I guess, let Chrissy know.